Ever wondered why real numbers are so essential in the world of differential calculus? Real numbers are not just a collection of digits but the very foundation for analyzing functions, setting limits, and determining derivatives. They are the bedrock upon which the magnificent structure of calculus is built. So when we talk about calculus, we are essentially discussing the fascinating world of real numbers. Now let's delve deeper into the key properties of real numbers that serve as building blocks for more advanced concepts in differential calculus. Did you know that real numbers remain real, no matter the arithmetic operation performed? This is known as the closure property of real numbers. Whether you're adding, subtracting, multiplying, or dividing, the result will always be a real number. Let's take a look at some examples. Suppose we add 2 and 3, we get 5, a real number. If we multiply 4 and 6, we get 24, another real number. So no matter the operation, the result is always a real number. Ever played with numbers and noticed that their order or grouping doesn't change the result? That's because of the commutative and associative properties of real numbers. The commutative property tells us that swapping the order of numbers in addition or multiplication won't affect the outcome. So, 3 plus 2 is the same as 2 plus 3. Similarly, the associative property means that grouping doesn't change the result. So adding 2 and 3 together and then adding 4 is the same as adding 2 to the sum of 3 and 4. But there's more. Real numbers also have what we call identity and inverse elements. 0 is the additive identity because adding 0 to any number leaves it unchanged. 1 is the multiplicative identity, as multiplying any number by 1 doesn't alter it. Every number also has an additive inverse and a multiplicative inverse, which bring the number back to its identity. These properties are like the basic grammar rules of the language of calculus. Have you noticed how addition and multiplication are connected in a unique way? This link is what we call the distributive property. It's a rule stating that multiplying a number by a sum is the same as multiplying that number by each term of the sum and then adding the products. For example, consider the expression 2 times the sum of 3 and 4. According to the distributive property, this is equal to 2 times 3 plus 2 times 4. Moving on, let's discuss the ordering of real numbers. Real numbers are neatly arranged on a number line. For any two real numbers, one of three conditions must hold. The first number is less than the second, the first number equals the second, or the first number is greater than the second. This order is crucial for understanding inequalities and limits in calculus. Getting a hold of these properties helps lay a solid foundation for your journey into differential calculus. Let's take a moment to recap what we've learned about the properties of real numbers in differential calculus. We've discovered the closure property, showing that arithmetic operations on real numbers always yield real numbers. We've explored the commutative and associative properties, which govern the order and grouping in addition and multiplication. We've delved into the distributive property, linking addition and multiplication. Plus, we've noted the ordering of real numbers, vital for understanding inequalities and limits. Mastering these basic properties of real numbers paves the way for understanding more complex concepts in differential calculus, leading to applications in various fields.